Welcome. Let's take a look at some of the properties of hyperbolic functions. Many of these properties mirror what we have seen before in trigonometric functions. For example, cosh squared of x minus sinh squared of x equals 1 might remind us of the trigonometric identity of cosine squared of x plus sine squared of x equals 1. However, notice there is a difference in the sign between these two identities. So there are identities for the hyperbolic functions that resemble the Pythagorean identities from trigonometry. There are identities that resemble the sum and difference identities that we see in trigonometry. There are identities that resemble the double angle formulas that we see from trigonometry, as well as the power reducing or half angle formulas. As these identities resemble those from trigonometry but are different, let's go ahead and take a look at proving one of the identities. Let's go ahead and take a look at cosh squared minus sinh squared equals 1. So to get started, cosh squared of x minus sinh squared of x is equal to 1 is what we want to show. Now cosh of x is e to the x plus e to the negative x over 2, and we're going to square that, minus sinh squared of x, so that is e to the x minus e to the negative x over 2 squared, and we want to show that that is equal to 1. So we're going to have to square both of those quantities. So starting with e to the x plus e to the negative x, if I square that, I get e to the x squared plus 2 e to the x times e to the negative x plus e to the negative x squared all over 2. And doing the same for our second term, so minus, and then we're going to have e to the x squared minus 2 times e to the x times e to the negative x plus e to the negative x squared over 2. Both of these denominators should be 2 squared equals 1. Now, before I go on, if you're wondering how I so quickly multiplied or squared those numerators, I was using a formula that is the perfect square formula. So a plus b squared is a plus b times a plus b, which is a squared plus ab plus ba plus b squared, and I can add those two middle terms to ab plus b squared. And the same is true when you have a similar process can be done with subtraction. A minus b squared is a squared minus 2ab plus b squared. So I simply applied my knowledge of these two relationships to those numerators. So you can go ahead and check that out. Okay, so let's go ahead and continue. E to the x squared, that's going to be e to the exponent inside of an exponent. You multiply using properties of exponents, so e to the 2x plus now e to the x times e to the negative x. That's e to the 0, and e to the 0 is 1. So 2 times 1 is 2. Plus, and then again for my next term, I'm going to have to multiply exponents, so that's negative e to the negative 2x. Notice both of my denominators are 4, so I'm just going to make this one large fraction and put that over 4. Continuing on, minus, and then now I have e to the x squared, so multiply those exponents and I get e to the 2x. I've got minus a negative, so this is going to be plus. And again, I've got e to the x and e to the negative x, which is e to the 0, which gives me 1. So that's going to be a plus 2, then plus e to the negative x squared, multiply the exponents, and I get e to the negative 2x. And we want to show that that is equal to 1. Now, I can go through and start combining like terms. So e to the 2x and a minus e to the 2x, those will add to 0. And then we have a positive e to the negative 2x. And I did not catch myself, made a mistake here. This negative should make that a minus e to the negative 2x. So now I have plus e to the negative 2x and a minus e to the negative 2x. And those should add to 0. So what are we left with? We're left with 0 plus 2 plus 0 plus 0 plus 2 plus 0. So simply we're left with 4 over 4, which is in fact equal to 1. Therefore, cosh squared minus sinh squared is in fact equal to 1.